is that we're actually somewhat, in some parts of the world, winning the poverty debate, and people are getting prosperous. And prosperous people like to eat, and prosperous people like to run air conditioners, and prosperous people like to take hot showers, and so on. And so we're starting to see an increased demand on the resource base of the world. How does that bump into us, into each other? And so there's a discussion going on out there, and Shell's been involved with it on three of the big sort of resource issues: food, energy, and water. And how do these things interact, and what can we do about it? So in the sense now, we're not sort of into how does Shell mitigate biodiversity in the field. It's sort of how does Shell, as a multinational, think about and deal with what looks like very big resource challenges going forward, and the interface between some of these resource challenges: water demand / scarcity, energy demand / scarcity, food demand / scarcity. And so the way the session is going to be set up is we'll have a presentation first from Allard from Shell, looking at how they're thinking about this topic and where it's going. Then after Allard's presentation, we will open it up for a few minutes of discussion, clarifying questions. Did anything make sense? You know, did he put up a slide that you'd like to go back and take another look at it, and so on. Also, you'll start with a little short video too. So we'll have a little video and then a PowerPoint presentation. And then we've got a panel group, which I'll introduce later, a couple people on the NGO side and a couple people on the corporate side. And we'll ask them each to sort of say, what do they think about this topic? And should we be looking at the space? And can we help Julia with Julia's vision of nature-based solutions for this topic of the water, energy, food interface? And then we'll open it up for discussion with the group. And you know, by about midnight, we'll be. Shall we start?
Yeah, thank you, Frank.
Do you know how to do the technology? I don't have a clue.
Well, if anything is to fail, that's probably the bit that'll fail, to be honest. Oops. No, this is good.
Show.
No, this is good. This is good. So far, so good. Bear with me.
We are, in a way. The rate
Sound it?
is against time. We have to build them. We need them, but we have to make them in a different way. We need a wave of innovation, not only for our way of life, but also for the planet. The consequences would be enormous if we lose this battle.
The world's energy, water, and food systems are tightly linked. Water is needed for almost all forms of energy production. Energy is needed to treat and transport water, and both water and energy are needed to grow food. In the coming decades, these vital resources will come under greater pressure. The world's growing population and increased prosperity will push up global demand for energy, water, and food supplies. The resulting planetary stresses are becoming known as the energy-water-food nexus.
One of the most crucial aspects of our energy modelling and scenario quantification is how much energy in total is the world going to use.
We're talking about the equivalent of a new city of 1 million people every week. That is an incredible demand.
The world will need 30% more water, 45% more energy, and 50% more food by 2030.
We understand demand will rise. We understand that current supplies will struggle to keep pace, so we have to, of course, find ways of bridging the gap between the demand and the supply.
The World Bank predicts an 85% increase in demand for meat between 2000 and 2030, and about 1,500 litres of water are needed to produce 1 kilogram of beef. In the United States, power generation accounts for 40% of all fresh water withdrawals. It's estimated that the food wasted in the US and Europe would feed 1.5 billion people each year. In order to solve all of these challenges, we need new ways of working, because these challenges cross boundaries between countries, industries, and the public and private sectors. That's why we will only progress solutions by working together.
Decisions that we take now are going to have a major impact on decades to come.
We can make a difference. by starting today. We can make a difference by powering progress together.
After this light-hearted intro with easy solutions, I'd like to share some pieces of work that we've been doing within Shell. My name is Allard Kastelin. I'm Vice President for Environment for Oil at Shell, and actively involved in the topic you just got an introduction on. I'm very pleased to speak here and share with you the challenges that we witness and share some of the thoughts and intentions. And I'll try and emphasize that this is not for one organization or one person or one perspective. We believe this is so complex that we all have a role to play, and that innovation, collaboration between private and public entities are needed to develop sustainable solutions. So in the video you saw an introduction of how this all kind of links, or at least you got an impression of some demand increases by 2030, and they are capped here again. But what do we mean actually by that resource scarcity? In a world that will be the home of 9 billion people, 2 billion people will actually be part of the middle class, driving a car, having a refrigerator, a television, and likely an iPad or an iPod, that all need energy. It's anticipated that by 2050, 75% of those people will live in cities. You heard in the video, the implication thereof is a new city of 1 million people once a week. Some of you are from as small of a country as I am, from the Netherlands. There's not a single city in that country that has 1 million people actually. We need to combine the 4 largest cities of the country, I think, to get to that number or about. That increase in demand of 30% more water, 40% more energy, 50% more food is a huge challenge. In the meantime, as we all realize and recognize, the world will want and need to stay within the 450 ppm of CO2 mark. So why does it matter for a company like Shell? We believe it's highly relevant, not only because the energy demand is growing, but also because energy production actually requires transport, requires water, and water transport requires energy. And so many of the elements of that nexus are very much interlinked. Water is needed to grow the food, and energy is again needed to produce that as well. So there is a very close link between these elements. And climate change is likely to intensify these stresses. We also believe that given that huge growth and given the current stress on the system already, we really have little time, not to say no time, to waste, and we have to get on with it. For instance, as you know, there's a lot of emphasis on biofuels nowadays. And biofuels may actually offer the fastest route to reducing CO2 emissions from the road transport sector. Yet, growing feedstocks in water-stressed areas could have a negative social and environmental impact, and it also may compete for food in that respect, which is of course something we would and should want to avoid. And I'll come back to the biofuels example later in the presentation. We believe that in Shell, we believe that placing sustainable development at the heart, at the core of our business, and I called it yesterday mainstreaming environment in your business decisions, is the only and the right approach. The long-term view, consideration for safety, environment, communities at the center of every step you take is necessary in order to provide the energy that we produce and must deliver in the right way. If we look at what actions does Shell take, it's actually trying not to overanalyze the situation. It's actually not trying to go back to the drawing board. We try to invest to understand the connections, but then translate that immediately to vital opportunities and actions. This slide, for instance, shows what I mean by that. A year ago, at Shell, we didn't have this oversight. You could argue that's strange, but this is to confirm to you that water, as such, has played and is playing an increasingly important role in our assessment. We studied our water consumption in detail, and we studied it against all the possible, if you like, energy sources we operate in or have connections to. It's also fair to say that when we started this, there wasn't even a fair accounting methodology that would make this possible. So we conducted research and developed methodologies in conjunction with some universities, and we published our findings. And this is actually the first time, and we're the only oil company that has been able to publish these reports, and they're publicly available, by the way. They're not intellectual property. And it captures the amount of water needed for the various sources of energy. Without going into detail, I'd like to point out one thing, which I believe is of interest, because often the development of shale gas is associated to a significant water usage. And as you can see, because shale gas is actually the third and the fourth bar from the left, although there's more water needed for shale gas development than there is for conventional gas, it is certainly not the most water-intense source of energy. What we're currently doing is that we are applying this knowledge and have brought that into our world and energy scenario work that we do, which Shell uses to assess the opportunities and the potential developments. So in addition to looking at energy as in a forward-looking way, we now also are looking at water in a very much forward-looking way and the implications thereof. And one of the ways that we actually applied this already is regarding our efforts in biofuels. You may have heard that Shell has invested in a $12 billion joint venture in Brazil, which produces ethanol from sugarcane. Such biofuels will actually create a 70% reduction in greenhouse gas emissions compared to normal fuels. And if you take into account that what wasn't mentioned nor in the video nor in the earlier slides, that the vehicle population will grow from 800 million to 2 billion. A 70% reduction in the source used, of course, makes a huge impact in tackling the climate change challenge. Now, the advantage of the sugarcane facilities in Brazil is actually this is purely rain-fed. So this doesn't draw on the, or doesn't compete, if you like, in this case, for water supplies with the population. Moreover, the Rising joint venture in Brazil recycles actually more than 90% of its water to ensure that water and residual water use is minimized. In the context of that other stress element of food, we've also made sure that in the area of Brazil, this acreage doesn't compete for food production, nor does it compete with the Amazon, for that matter. It lies hundreds of kilometers from the Amazon rainforest, and it is agriculture land already and has been for many decades. However, with IUCN and other European Union entities, we also have made sure that this element of indirect land use change is properly addressed and taken into account when folk are promoting more use of biofuels. Another example I'd like to share with you related to this Nexus work is our GTL facility, gas to liquids we call that, which, although it's a huge manufacturing facility, it's located in Qatar, clearly a water scarce area. The process needs a lot of water, yet because of the constraints, our technology folk have managed to develop a process where the water is actually treated in such a way that no water is No draw on fresh water is necessary, and the treatment facility has a capacity of 280,000 barrels a day. And I don't know whether there's any water experts in the audience, but that, I've been told, is comparable to a plant for a town of 140,000 people. Of course, we wouldn't have done that because clearly this is essential for the area and the local communities. And if we hadn't been aware of the issue and we hadn't taken it into account, we may easily have made the wrong choices in that respect. The third slide, or third example I'd like to share with you, confirming the importance, is our Oman reed bed facility. This is in Oman we actually produce more water than we produce oil. We produce 1 barrel of oil for, and at the same time we bring up 10 barrels of water. And rather than going for a manufacturing facility to clean the water or to re-inject the water, which is not aquifer water as such, it's not potable water, not cannot be used for societies. Rather than re-injecting it, which will also cost energy and thereby aggravates the climate change challenge, we've actually chosen to develop a 235 hectares of facility cleaning the water through a natural process using reed beds and gravity. The microorganisms eliminate the contaminants, and biomass is produced as an energy source. And this entire facility does not need any additional energy supply, and it has a capacity to clean 47,000 cubic meters a day. And we're even looking to expand it in the future. So let me now move to this issue of collaboration. Because, as I said, we do believe that new models and new leadership is necessary to progress these huge challenges. And it's only through collaboration with governments, business, civil society, local communities that we can actually work such challenges. And we would hope that major international companies like Shell, but also NGOs like IUCN, can play a role in addressing these issues across these various industries and sectors. This is a map of the world with a couple of dots on it, but Shell is very proud and pleased with the fact that we have a structural collaboration with 4 NGOs, Earthwatch International, or yes, Earthwatch Institute, I should say, my apologies, Wetlands International, the Nature Conservancy, and IUCN. And we actually work with these NGOs in more than 35 projects around the globe to address, to a certain extent, a number of the concerns I've just alluded to. Yet, we do think, however, that new tools are necessary and new approaches are necessary to take it a step further and begin to address in more detail the resilience issue. So let's now move to that resilience issue. Here, I'm pleased to confirm that a number of international large companies have taken the step to collaborate at the initiative of Shell CEO Peter Voser to start working these various issues, to start working and begin to address, if you like, the stress nexus perspective from a wider perspective than the traditional value chain. Normally, businesses develop their business to optimize within that value chain. They look for locations, their sources of supply, their interactions, their products, and that tends to be within the normal traditional value chain modeling. Now we are working with 9 other companies, and we're looking for the synergies, and we're looking for the overlaps, and we're looking for the new business models that actually may address that element of stress, food, and water. In that, and this initiative was kickstarted early this year, so less than a year ago. And in that, we've also said what we actually need is pilots. We need proof, we need evidence, we need action, rather than we need studies, we need analyses, we need scientific data. Because we're not going to challenge the scientific data, we're going to accept that resilience, challenge, and stress is a fact of life. So rather than focusing on the intellectual bit, I would say, we're urging and steering our teams to work across their own areas of comfort to assess, for instance, a smarter city development. As I said, 75% of folk will be living in cities, so you can think of smarter mobility, but you can certainly think of smarter infrastructure. You can certainly think of ways to combine energy supplies, waste, heat, water in larger areas in a much, much smarter way than we have in the past. A similar example is related to an element of green infrastructure versus grey infrastructure. What do I mean by that? Take the Oman example again. We would define a water treatment plant as grey infrastructure, where engineers develop something that requires steel and concrete and energy. Green infrastructure for us is, okay, a reed bed facility, or like a project that we've deployed with the Nature Conservancy, oyster reed beds in the Gulf of Mexico to protect the coastal erosion of the shoreline. And as you know, the Gulf of Mexico has a huge pipeline infrastructure, so it serves several purposes. The system that we are trying to apply, and I hope you appreciate that, has in the center